So chapter 3 deals with right triangle trigonometry. A right triangle is a triangle with a right angle in it. Okay, a right triangle is a triangle that has a right angle, a 90-degree angle. It's a triangle that contains one right, in other words, 90-degree angle. So what we're going to be learning about in this chapter is we're going to be learning about how we can find missing sides and missing angles in right triangles using something called SOHCAHTOA, which is what that thing is that's kind of flashing there on the screen. Okay, so we'll see what that is. We'll see how we use it, but we're going to be using what are known as trig ratios to find missing sides and missing angles in right triangles that have a 90-degree angle in them. What do we already know about right triangles? Well, we know that Pythagorean theorem works for right triangles. Remember, that's a squared plus b squared equals c squared. So a and b are the two legs of the triangle, and we could switch those two sides around, meaning the one that goes upwards, we could say that is B, and the one on the bottom is A. It doesn't matter. But the hypotenuse is always the side across from the right angle. That's always C. And Pythagorean theorem says that A squared plus B squared equals C squared. So we will be using Pythagorean theorem in this chapter because we're going to be working with right triangles. And that will be the strategy that we use in some cases to find a missing side of a right triangle, but not always. You can only use Pythagorean theorem if you have two sides of a right triangle. We're going to see some cases where we have only one side and an angle other than the 90-degree angle, and we'll use what's known again as a trig ratio to find the missing side. So this part here we've worked with before. That's nothing new. But as we start working towards these trig ratios, we have to know how to label the sides of a right triangle appropriately. So we've always said that the side across from the right angle is the hypotenuse. So let's label that side as the hypotenuse. It's across from the right angle. But we're also going to have two other sides. We're going to actually label the other two sides of the triangle. And they will be labeled according to which angle you're going to be working with. In this triangle here, you can see the check mark in that bottom right-hand spot. That means that's the angle we'd be working with for a problem. Well, the side across from that angle is known as the opposite. It's opposite the angle that you're going to work with. And then the third side is the adjacent. Adjacent means beside. It's beside the angle that you're working with. Now, the hypotenuse is also beside that angle. However, that side's already been labeled. The hypotenuse is always the side across from the right angle. That never changes. The opposite and the adjacent sides, though, they might change. They will be labeled according to the acute angle. An acute angle means less than 90. So the opposite and the adjacent will change because the side across from the acute angle that you're going to be working with or using is always labeled the opposite, and then the third side is the adjacent side. So this is something that we're going to be doing in most of our problems in this chapter. labeling the three sides of the triangle. So we have what are known as trig ratios that we're going to be using here. So you could take a ruler and measure these sides, okay? You can also, before you start measuring sides, take a ruler and draw the hypotenuse of that triangle. So on your page, if you draw your hypotenuse and then you use a ruler and you measure the lengths of the sides. So the length of the hypotenuse, if you use a ruler, will be 6.4 centimeters. So let's write that in there. Okay. And let's also label the angle at the top to be angle A, the angle at the bottom to be angle B. Angle C is already labeled. That's your right angle, your 90-degree angle. So again, you can take ruler and measure the sides. This side will be 6.4. This side will be 3.3 centimeters. And the bottom, the base, is 5.5 centimeters. So taking a ruler and measuring those sides, that's what you would get. Okay? You can also use a protractor to measure angles. And you're not going to have to physically know how to do that, but I mean, it's if we type in protractor here, try that again. Right, so there's what a protractor looks like. That's a tool that you can use to measure angles. To measure it, you put the kind of the sight of the protractor right where the angle is that you're measuring, and then you measure from the zero line up, and that looks to be about 31 degrees. That's how the protractor is used. That's the measure of angle B, 31 degrees. And you can do the same thing to get the measure of angle A. It would be 59 degrees. 59 degrees. So let's work on the angle A line. So we're going to work our way across the angle A line. We have the length of the hypotenuse. The next column asks for the length of the opposite. So if you are using angle A in this case to solve a problem, if you're going to use angle A to solve a problem, we can label the three sides of the triangle. The side across from the right angle never changes. The hypotenuse will always be 6.4. But if you're working with angle A, the side across from there is the opposite, and then the third side would be the adjacent side. If you are working from angle A, the side across from angle A is labeled the opposite. So the length of the opposite side from angle A is 5.5 centimeters, and the length of the adjacent side to angle A is 3.3 centimeters. Then it asks us to write these ratios. What is the ratio of the opposite over the adjacent? The opposite is 5.5, divided by the adjacent, which is 3.3. If we take our calculator and we figure out what that is as a decimal, 5.5 divided by 3.3 is 1.6 repeating. Or if we round to the nearest tenth, 1.7. Then it asks us to take the length of the, the opposite and divide it by the length of the hypotenuse. So that'll be 5.5 over 6.4. 5.5 divided by 6.4 is 0. If we round that to one decimal, 0.9 approximately. And if we go the length of the adjacent, which is 3.3 divided by the hypotenuse of 6.4, and we round to the nearest tenth, it's approximately 0.5. And we're going to see why these numbers matter here in a few minutes. We're going to see what these numbers mean, why we're doing this work now. So then the next line will be for angle B, if you're working from angle B. So instead of angle A, we're going to work from angle B. So that's where your angle is. And that will change the opposite and the adjacent sides, because now the side across from angle B is the opposite, and the third side, the other side, is the adjacent side. So if you're working from angle B now, the opposite and the adjacent sides change. Sal, you with us? So now if we fill this in, the length of the opposite is now 3.3. And the length of the adjacent is 5.5. So now when we go, opposite over adjacent, it'll be 3.3 over 5.5, which we already did above here. No, we didn't. We did 5.5 over 3.3. So here it's 3.3 over 5.5. That's 0.6. Don't have to round that one. Opposite over hypotenuse will be 3.3 over 6.4, which we did above. That's approximately 0.5. And adjacent over hypotenuse will be 5.5 over 6.4. And above, we went 5.5 over 6.4 and got 0.9. So there's those values. Now, on your calculator, you need to find these three buttons. Sin, which stands for sine, cos, which stands for cosine, and tan, which stands for tangent. You need to find those three buttons because we're going to be using them in this chapter. In order for this to work, your calculator has to be in the correct mode. The correct mode for this is the degree mode. So on a TI calculator, the mode key is in the very top there, second column, top row, and you need to have degrees highlighted. It's on the third line. So right now my calculator has radians highlighted. So we need to use the arrows to go down and over to degrees and then hit enter. And now degrees is highlighted. Other calculators will have a mode key somewhere, but you need to be in degree mode. On some calculators, you will see a button that says D, R, and G. And every time you press it, the mode will change. You need to be in degree mode. So to make sure that your calculator is in the right mode, hit the sine key and type in 30. This is the sine of 30 degrees. If you hit enter, you'll get exactly 0.5. If your calculator is in the right mode, when you go sin 30, you'll get 0.5. Now, some calculators you have to put in the angle first, 30 degrees first, and then hit the sine button after. So you need to be trying this on your calculator right now so that you know how your calculator works, and also making sure that you're in the correct mode. Is everyone okay? Your calculator is working properly? You take the sine of 30, you get 0.5. Okay? So now, the next thing asks us to write the sine of angle A. Well, angle A is 59 degrees. So we'll take our calculator and we'll go the sine of 59. And we'll round it to the nearest tenth. That's going to be 0.9 to the nearest tenth. Then it asks us to find the cosine of angle A. So we'll do that. Cos of 59 degrees. That equals 0.5. And then the tangent of angle A, the tangent of 59 degrees. And that equals 1.7, rounded to the nearest tenth. Now, if you look on the row here for 59 degrees, you see these same three decimals. When we took the sine of A, we got 0.9. Well, that's this decimal right there. We got that decimal by taking the ratio of the opposite over the hypotenuse. That gave us 0.9. 0.5, which was the cosine of angle A, or the cosine of 59 degrees, well, there's our decimal 0.5. That decimal came by dividing the adjacent by the hypotenuse. We got the same decimal. And the 1.7 number, that's right here, that came from dividing the opposite over the adjacent. So what this tells us then, the sine, which was 0.9, came from the opposite divided by the hypotenuse. So let's write that down. The sine of the angle, 59 degrees, came by dividing the opposite by the hypotenuse. So I just kind of use abbreviations there. The cosine of 59 degrees, which was 0.5, that came from dividing the adjacent by the hypotenuse. This was the adjacent side divided by the hypotenuse. And the last one is our tan ratio. The tan of 59, when we did it on our calculator, we got 1.7. We got that from the diagram by dividing the opposite by the adjacent. So from that triangle, we got those values two different ways. The first way was by dividing, taking the ratio between two sides, and then when we used our calculator, we got the same decimals, and then we just compared them. Where did we get each decimal from? So now, what about angle B? Angle B is 31 degrees. So now if we take the sine of 31, that is 0.5. The cosine of 31 is 0.9. Again, we're rounding to the nearest tenth. And the tangent of 31 is 0.6. So if we compare these three decimals to the decimals we have for the angle B row, 0.5, well, we got 0.5 by again dividing the opposite by the hypotenuse. That gave us the same decimal for the sine, which matches what we did for the sine of 59. We divided opposite by hypotenuse. The 0.9 that came from the cosine, well, in this row, there's your 0.9. and that's the ratio of adjacent over hypotenuse, which is the same thing we got for 59 degrees. The cosine of 59 was also adjacent over hypotenuse. And the 0.6 comes from this calculation there, which is the opposite over the adjacent, and that is our tangent, opposite over adjacent. And we took the tangent of that angle to get that decimal as well. So what this tells us, it tells us what the definitions are for sine, cosine, and tangent. And this is what SOHCAHTOA is used for. Keen. This is what SOHCAHTOA is used for. The S stands for sine. Sine is opposite over hypotenuse. That's what the O and the H stand for. Not only does that tell you what the two sides are that you use for sine, but they also tell you what order they're in. It's O first, H second. Opposite on top, hypotenuse on the bottom. The Ka part stands for cosine. It tells us that cosine is adjacent over hypotenuse. Not only does it tell you what two sides you're using, but it also tells you the order. And then the T part is your tangent. Tangent is opposite over adjacent. So you can use these to remember what the trig ratios are. But if you look on your formula sheet at the back, the trig ratios are there for you. Right? The triangle is labeled and the three trig ratios are on your formula sheet. So you don't have to memorize them. You're going to be given them on the formula sheet. Okay, so we found that the sine, cosine, and tangent ratios were ratios of the sides of the right triangle. Okay, so we saw that those ratios come from the right triangle. So we always start by labeling the sides of the triangle. The hypotenuse is always the side across from the right angle. That never changes. This theta here tells us that that's the angle that we're working from or with. The side across from that is the opposite. The third side is the adjacent side. So this is what we're always going to do. Okay, Brooklyn? And the ratio of sine is the opposite over the hypotenuse. Again, it's on your formula sheet. You don't have to memorize this. The ratio of cosine is the adjacent over the hypotenuse. And the tangent is the opposite over the adjacent. Those are our three ratios. So they're on the formula sheet. You don't have to memorize them, but you can use SOHCAHTOA to help you remember what they are. So this first example says write each trig ratio. First, let's do from angle B. So if we're using angle B, let's label the three sides. The side across from the right angle is the hypotenuse. That never changes. From angle B, the side across from that is the opposite. Then all you're left is one side for the adjacent. If you were using angle B, that's how you must label the sides. You will never work with the 90-degree angle with SOHCAHTOA. Okay? And there's a couple of reasons why. We'll talk about one right now. We'll see another reason a little bit later. If you said you're working from angle C, then you would say the side across from that is the opposite. But you can't write that the opposite because it's already the hypotenuse. So that's one reason why you can't use angle C. Okay, and we'll see another reason as we get deeper into this chapter. So when you're doing the sine and cosine and tangent of an angle, it's always going to be one of the two smaller angles. The angle's less than 90 degrees. So tangent of B, remember, tangent is opposite over adjacent. So from angle B, the opposite side is 3, the adjacent side is 4. For that triangle, the tangent of B will be 3/4 or 0.75. Let's do all the angle B ones. So let's slide across and do the cosine of B. The definition of cosine is that it's adjacent over hypotenuse. So for that triangle, the adjacent side is 4 and the hypotenuse is 5. And then we want to do the sine of angle B. The definition of sine is opposite over hypotenuse. So that'll be 3/5. So there's your 3 ratios for angle B. So now if we want to do angle A, so now we're going to work from angle A instead. That doesn't change the hypotenuse. However, the opposite and the adjacent sides will change. Because now we're working from angle A. The side across from that becomes the opposite. The hypotenuse doesn't change. So now 3 is the adjacent side. Jensen, what's the sine of angle A? What's the sine of angle A as a ratio? Is that your final answer? What's the sine of angle A? That's my question. We just found the sine, cosine, and tangent of angle B. Now we're switching to angle A. Maybe you should stay off your phone and pay attention. Yes, Jan? Huh? No, we've already done sine, cosine, tan for angle B. Now we're working on angle A. The sine of A, the definition of sine is that it's opposite over hypotenuse. So from angle A, the opposite is 4 over the hypotenuse, which is 5. Pardon me? I can't hear you. Are you okay? All right. Cosine of angle A. The definition of cosine is that it's adjacent over hypotenuse. So from angle A, the adjacent side is 3 and the hypotenuse is 5. That's the value of the cosine of angle A. And the tangent of angle A, the definition of tangent is opposite over adjacent. So from A, the opposite is 4 over the adjacent, which is 3. So that one is done. Note, the sine of A and the cosine of B have the same value. They're both 4/5. Also, the sine of B and the cosine of A have the same value. They're both 3/5. The last thing, the tangent of the two are reciprocals of each other, 3/4 and 4/3. One more thing that we're going to see happening. The sine and cosine of every angle in a right triangle will always be a decimal less than 1. Cheney, do you want to give Brock a tap on the shoulder, please? The sine and cosine of every angle will be something between 0 and 1. But tangent can be greater than 1. In the case of the tangent of angle A, it's 1.3 repeating, greater than 1. But the sine and cos will always be a decimal between 0 and 1. So let's do the same thing now with this next triangle. So let's start with M first, angle M. The hypotenuse never changes. It's always the side across from the right angle. But if you're working from angle M, the side across from that is the opposite. The third side is the adjacent side. And the tangent of M. You have to remember that tangent is opposite over adjacent. It's on the formula sheet. It's there for you. So from M, the opposite is 12, and the adjacent is 5. That's a decimal greater than 1. It's actually 2.4. And tangent can be greater than 1. So let's finish off the other two ratios from angle M. The cosine of M. Cosine is adjacent over hypotenuse. 5 over 13, again, between 0 and 1. Brock, what's the sign of m? Okay, you need to stay with us, okay? Definition of sine is opposite over hypotenuse. That's 12 over 13. So again, the sine and cosine are decimals between 0 and 1. The tangent can be greater than 1, and in this case it is. So those are your three ratios from angle M. Now, what if we went to angle N instead? So now we're going to go to angle N instead. It just doesn't change the hypotenuse. That never changes. It's always the side across from the right angle. But now the opposite and the adjacent sides change. The side across from angle N is the opposite. It's opposite angle N. So now, the sine of N. What's the sine of N, Olivia? 5 over 13, because sine is opposite over hypotenuse. It's on your formula sheet. The cosine of angle N, Liam? Yeah, adjacent over hypotenuse. It's on your formula sheet. So again, the sine and cosine are both decimals between 0 and 1. What's the tangent of angle N? Cheney? Opposite over adjacent. 5 over 12 is right. So we are going to use these, as I said at the start of class, we're going to use these ratios to help us find missing sides and missing angles in right triangles. That's what they are used for, to find missing sides and missing angles in right triangles. So before we get there, we need to again be able to use our calculator with sine, cosine, and tangent. Since all angles we encounter will be expressed in degrees, again, we need to be in the degree mode. So we've already talked about that. So take your calculator and find the sine of 25 degrees. So the same way you did the sine of 30 degrees before to get 0.5, take, in this case, the first one is the tangent of 25. And it says round to 4 decimal places is 0.4663. That's what you should get. And everyone should be doing this to make sure your calculator is working properly. Make sure you know how to use your calculator. Jensen, what's the sine of 42 degrees? Yep. Round it to 4 decimal places. And then the cosine of 68, 0.3746. Right? Now, sometimes you're given what the sine, cos, or tangent is as a decimal, and you want to find what angle corresponds to that. So on your calculator, that's where we use the sine to the -1, the cos to the -1, and the tan to the -1. That means inverse. Inverse of sine, inverse of cos, inverse of tan. So if the tangent of theta, and theta is just a Greek letter, and it's often used to represent a missing angle. So we're going to see that quite a bit. Theta. It's a Greek letter. It's often used to represent a missing angle. So if the tangent of the missing angle is 1.2115, and you want to know what theta is, this is where you'll go tan to the -1 of that decimal. That's what you're going to put in your calculator. So in my calculator, I got to go second function first to get what's above tan, to get tan to the -1. I'll put that decimal in there and hit enter. and it tells me what the angle is. To the nearest degree, the tangent would be 90 degrees. So theta is approximately 90 degrees. Something's not right there. I missed the decimal. That makes sense. I need to put the decimal in there. There we go. That's better. 50 degrees. 50 degrees. Okay? So for the second one, if you're told that the sine of angle beta, so again, that's just a Greek letter, is 0.4771, and you want to know what angle beta is, we need to do sine to the negative 1 of 0.4771 in our calculator. Second function sine of 0.4771. So approximately 28 degrees to the nearest degree. So that's what angle beta is. Approximately 28 degrees. And question C says the cosine of gamma. Again, that's just a Greek letter. For some reason, mathematicians have often used Greek letters to find missing angles. So if you want to find out what angle gamma is, you need to do cosine to the negative 1 of 0.7225. So on the calculator, that's second function cos of 0.7225, which is approximately 44 degrees. If we round to the nearest degree. All right. It says complete the table, record the ratios to 4 decimal places and the angles to the nearest degree. So the first one, you're given what angle theta is, and you want to state the sine, cosine, and tangent of angle theta. So the sine of 27, you should know how to do this on your calculator now. The 4 decimal places is 0.45399, so we'd actually have to round that to 0.4540. Rounded to 4 decimal places. The cosine of 27 degrees, 0.8910 to 4 decimal places. And the tangent of 27 is 0.5095 to 4 decimal places. 5095. Right? Now for the next row, we're given what the tan of theta is. The tan of theta is 0.5543. To find out what angle theta is, then we must go second function tan of 0.5543. And to the nearest degree, theta would be 29 degrees. And so now that we have theta, we can find the sine and cosine. The sine of 29 is 0.4848. And the cosine of 29 is 0.8746. So there's that line done, that row. For the next row, we're told what the sine of theta is. It's 0.4384. So we must start this one by going second function sine of 0.4384. And theta, the angle, is 26 degrees. And so now we can find the cosine and tangent of 26. The cos of 26 is 0.8988 if we round it. and the tangent of 26.4877. And for the last row, we are told that the cosine of theta is 0.2079. So to find theta, the only way we can do it is by going second function cos of 0.2079. It tells us that theta is 78 degrees. And so now we can find the sine of 78.9781 and the tangent of 78, 4.7046. Remember we said that the sine and cosine of every angle will be a decimal between 0 and 1. That's true. The cosine, however, can be greater than 1, which is true for 78 degrees, but it can also be less than 1. So again, we will use our trig ratios in order to help us find missing sides and missing angles in right triangles. So this next question is an example of where we will do that. Again, these only work with right triangles. So you have to have a 90-degree angle triangle. So I'll start by drawing a right triangle. We're asked to draw a triangle to represent that the tan of theta is 5/4, and then calculate angle theta to the nearest tenth of a degree. So remember that whatever angle you're working from, it'll never be the right angle. The right angle is a 90-degree angle. You'll never work from that. So that means we have to either label the top angle as theta or the bottom. And it doesn't matter which one. It just can't be the right angle. Let's put it at the bottom. So this now allows us to label the sides of our triangle. The side across from the right angle is always the hypotenuse. That never changes. If we're saying theta is the angle at the bottom, the side across from that is known as the opposite. The third side is the adjacent side. And we are told that the tan of theta is 5/4. Tangent, by definition, is opposite over adjacent. That's the definition of tangent. It's on the formula sheet. The TOA part of SOHCAHTOA tells us that, which means that the opposite side must be 5, and the adjacent side must be 4, because tangent is opposite over adjacent. So the opposite has to be 5, and the adjacent has to be 4. So there we've labeled that triangle. We've drawn and labeled the triangle. Then it asks us to find angle theta, which you didn't even have to do this, draw the triangle to get that. We did it because it told us to, but we didn't even need to do that. If we are told that the tan of theta is 5/4, we can find out what theta is by going tan to the -1 of 5/4. We've already done examples like this before where instead of a fraction, it was a decimal, but it's done the same way. Instead of the tan of theta equaling 5/4, if you wanted to, you could take your calculator and divide 5 by 4. That would give you 1.25. So it's no different than we have been doing. To find out what theta is, we would go second function tan of 5/4. To the nearest tenth of a degree, theta would be 51.3 degrees. Surveyors use trigonometry all the time. An example where a surveyor might do something like this, maybe they're trying to find the height of a tree. They can use a trig ratio to find out what the height of the tree is. Now, they wouldn't have the opposite side, but maybe they have the adjacent side and they know what theta is. We're going to see that, you can use SOHCAHTOA to find the height of that tree. If you know the adjacent side, how far the surveyor is from the base of the tree. And surveyors have special tools that they use to measure angles. So they could measure what the angle to the top of the tree is, and they can use a trig ratio to find the height of that tree. Okay? And we'll see examples of that. Number 5 says draw a triangle to represent that the cosine of theta is root 5 over 3. So as soon as you say it's a triangle and you're talking about either sine, cos, or tangent, it has to be a right angle triangle. So we start by drawing one. So there's our right angle. Again, you can let one of the other two angles be theta. It doesn't matter which one. In the last example, we let the bottom angle be theta. This time I'm going to let the top be theta. It doesn't matter. However, now that we've said that that's theta, we need to label our sides. The hypotenuse never changes. The side across from the angle that you're working from is the opposite. The remaining side is the adjacent. We're told the cosine is root 5 over 3. The definition of cosine is that it's adjacent over hypotenuse. So the adjacent side has to be root 5. The hypotenuse has to be 3. The definition of cosine is adjacent over hypotenuse. You're asked to state the exact value of the sine of theta. So to do that, the definition of sine is opposite over hypotenuse. So we need to know the length of the opposite side before we can state sine. To do that, we will use Pythagorean theorem. So we'll say that A is root 5. That's one of the legs of the right triangle. We need to find out what the other leg B is. The hypotenuse is 3. So root 5 times root 5 is 5, plus B squared equals 3 squared, which is 9. Subtract the 5 from both sides, and B squared would be 4. The square root of 4 is 2. There's the length of the opposite side using Pythagorean theorem. So now we can state the exact value of the sine of theta. Again, it's opposite, which is 2, over hypotenuse, which is 3. There's the exact value. The exact value tells us that we'll leave it like that, because if you turn it to a decimal, you'd have to round it, and it's no longer exact. So it stays like that, 2 over 3. All right? So there's some questions that you can work on. I will post those solutions to Google Classroom so you can check your answers. This stuff is not hard, but you still have to practice it so that when it comes time for a quiz or a test, you're ready. You're familiar with what you need to do. Okay, I need you to clear off your desk. You're going to do your Chapter 2 quiz. I will give you a clean copy of the formula sheet, so you can put that away as well. Don't forget, June 9th is the last day to hand in any missing assignments. After that, they go in as zeros. So you need to get working on that to make sure that you're ready